system of equations. Can somebody quickly tell me how would you think we should get started with solving this system of equations? What would be the first step, do you think?
Finding a variable to easily isolate, or not isolate, excuse me, finding a variable to easily cancel out.
Yeah, find a variable. So if you look at the middle one, what's missing on the middle one? What variable is missing in the middle one? Y, right? So what do I have to do with the first two then? I'll pick the first two equations, and then I'll try to eliminate Y. Does that make sense? So this is one way to do it. If I pick the first two equations like that, and then eliminate the Y, because Y is missing in the middle one, see? To do that, if I look at the coefficient of Y, the coefficient of Y for the first one is -1, coefficient of Y for the second one is 4Y. If I multiply the top row by -4, or in this case +4, because this is already minus. If I multiply the top row by 4, you see how the coefficient of Y becomes opposite of each other? So if I simply add this equation and this equation, you get the equation in terms of X and Z, just like you had in the second one. So if I take this equation and the second equation, then you have two equations and two unknowns, where I can do the same thing. I can, this time, eliminate the Z. See, the coefficient of Z here is 1, coefficient of Z here is 9. If I multiply the top row by -9, I can add these, and now Z cancels, and it turns out that -36x plus 5x would be -31x equal to 0. In this case, x turns out to be 0. Once I find x, I can plug it back into either of these two equations. I put it into this first equation, and I solve for Z the same way. So I find x equal to 0, Z is equal to 0. If I take these information and plug it back into any of these equations, I can solve for Y. So I just plug those into the first equation, and then I find Y is equal to -2. And that should be the choice here. That D should be a correct answer here for this one. Question, anyone? That's how to solve a system of equation. If all the variables are present, then you could simply pick the first two equations, eliminate one variable, take the next two equations, eliminate the same variable. You get two equations and two unknown again, and you can solve all the variables the same way I showed.